All right, our next major topic is similar triangles. And in Module 1, we talked a lot about congruent triangles. And congruent triangles are exactly the same. Same shape, same size, like two triangles that are literally exactly the same. Similar is a little bit different. Now, what similar means is the exact same shape, but they can be different sizes. You can have a big one and a small one. That would still count as similar. So it's kind of like congruent, but it's not the same. They can be different sizes, but they do have to be the exact same shape. Now, as far as our triangles, what that means for us is that the angles are still going to be congruent, just like for congruent triangles. The angles will be exactly the same, but the sides are not. The sides can be bigger or smaller in one of the triangles. Now, what the sides actually are proportional, meaning they make proportions, which is exactly what we studied in our last lesson. So I said, for example, the sides of one triangle might be exactly 3 times as big as another. And here's an example of that. So if you match up these sides here, this side right here is 3, and this side right here is 9. That's exactly 3 times bigger because 3 times 3 is 9. Now if the triangles are similar, then that same proportion, that same ratio should match up for all of the sides. So let's check and see if it does. Right here, this side is 5. 5 times 3 is 15, so that one checks out. And then for the last side, right here, this one is 4. 4 times 3 is 12. So what you can see in these two triangles is that, yeah, they are proportional. However big the smaller one is, each side of the bigger triangle is exactly 3 times bigger. Now, that number can be anything. You can have a triangle that's 2 times bigger, or 100 times bigger, or 1.73 times bigger. It doesn't have to be a whole number or anything like that. But one triangle, all the sides are proportional. You're multiplying by the same number each time. Now, if you kind of work that process backwards, what it means is if you can see all the sides, then what you can do is divide and see if you get the same number each time. So the way I presented on the last slide, I said, okay, if you take 1 and you multiply by 3, you get the other ones. Well, if you have them all in front of you and you want to check to see if they're similar, you can just divide. You go 9 divided by 3 is 3. 12 divided by 4 is 3. 15 divided by 5 is 3. Because I got 3 every single time, that means they're proportional. Now that number is called the ratio of proportionality. So that number 3 from our last example, and it can change for other problems, but that number we call the ratio of proportionality, and it's basically how many times bigger the bigger triangle is than the smaller one. So let's take a look at this one and figure out what the ratio of proportionality is. So if I match up sides again, let's start with this one and this one. I have a 40 and a 4. If I divide them, 40 divided by 4 equals 10. Now I don't know anything yet. What I want to do now is check and see if I divide the other sides if I get the same number. So next, let's match up the 50 with the 5. And I go 50 divided by 5, well that one also equals 10. Let's check our last one. I have a 60 and a 6. 60 divided by 6 also equals 10. So every time I divided sides, I got a 10 and a 10 and a 10. That tells me that these triangles are similar, the sides are proportional, and the ratio of proportionality is 10. Now, one thing I want to warn you of, when you're testing sides, make sure you're careful when you match them up. On the last example, I drew the triangles right next to each other, so it was real easy to see which sides matched up with which one. But if I flip the triangles or I spin them around, it can be a little bit confusing. So what I said here is when you're doing your test, make sure you always match up the biggest with the biggest, the smallest with the smallest, and the middle with the middle. So if I'm going to do that same test for this one right here, let's try the biggest side first. So I look at my triangle over here on the left. The biggest side is the 20. And I look over here on the right, the biggest is the 24. So I do 24 divided by 20. We might want a calculator for that, but it does come out to 1.2. All right, let's try the same thing with the smallest sides of each one. So the smallest side in this triangle is the 10, and the smallest number on the other triangle is the 12. So I do 12 divided by 10, which also equals 1.2. Let's check the middle side and just make sure we got it right. So the middle side is the 15 and the 18. I do 18 divided by 15, and I get 1.2 again. Again, you can use a calculator for that. But basically, these triangles are similar, the sides are proportional, and this time the ratio of proportionality is 1.2. Remember, I told you, it doesn't always have to be a whole number, you can get decimals. So basically what we're saying here is the bigger triangle, the one on the right, is 1.2 times bigger than the one on the left. And we had to match up sides to do that. And also the other thing I did when I was dividing, I always did the bigger side, the bigger triangle, divided by the smaller triangle. But within that, I matched up the sides of each one. I took the smallest side of each triangle, tested, the middle, and the biggest. All right, so let's do this. The two triangles below are similar, I'm telling you that. Let's find the ratio of proportionality and the missing side. So when I look at what's given to me, there's two blank sides that I don't know anything about. In one triangle, I said the bottom side is 4 and the left side is 5. And in the other side, I said the bottom is 8 and the left is x. So x is what I need to solve for. But before I can solve for that, I need to use the ratio of proportionality. And to find the ratio of proportionality, I'm going to use the two sides that are matched up. So the two sides that match up in my triangles, the big one is 8, the small one is 4. So I'm going to do 8 divided by 4, which is 2. And that is my ratio of proportionality. Oops. Ratio of proportionality. Now, once you've figured that out, you're going to use it for the second part of the question. Because see, now I want to solve for x, and what was given to me is I have a 5 here. Now that I know that the other triangle is exactly 2 times bigger, I can just multiply by 2 to find x. 5 times 2 is 10. So x would have to be 10 in that problem. So we were doing two separate questions, but really you can't do the second one until you figure out the first one. The first question, we were figuring out the ratio of proportionality. And then the second question, we were using that number to find missing sides within one of the triangles.